All right, today we are going to cover composite functions, all right? And there's gonna be some terminology, there's gonna be some notation stuff that you have to get straight. We'll talk a little bit about domain and range, but usually in the context of things that you're already familiar with. So, for starters, here's what a composite function is. It is made by using one function as the input value for the other function. So essentially what we're going to have is two functions. Sometimes you could have three, but you got to have at least two. And if you think about when we evaluated functions before, we'd say f of 3, and we'd take 3 and we'd plug it in everywhere there was an x, and we'd figure out what that was. And then we graduated to like putting an expression in f of x squared, and we'd take x squared and we'd put it in wherever there was an x. Well, now what we're going to do is we're literally going to take one function and put it as the input value in the other function, and then we'll reverse it. Okay? That's how you make a composite function. It is composed of one function composed of two functions. Okay? Now the notation, here's where it gets tricky. Okay? This open circle means f of g of x. This also means f of g of x. Sometimes you'll see it written like this, with just parentheses. Okay. All three of these things mean the same thing, and you need to know how to use them interchangeably. Okay. They all mean the same thing. Don't be confused with the closed circle that we looked at yesterday that meant multiplication. This is an open circle, and it means a composite function, f of g, and it's of x. All the functions are going to be in terms of x. Now, what this is telling you, the order matters, right? The order of all these things matter. The g comes second, the g comes second, the g comes second. That is telling you that what the input value is, bless you, what the input value is g. The sort of base function that we're going to be looking at is f. So what we're going to be doing is taking g of x, whatever it is, we're going to use it as the input value into f. Okay? And that's what it says. G of x is the input value into f. Now, we can reverse the entire thing. And instead of having g as the input value, we can have g as sort of the base function and f as the input value. Here's what all of that would look like flipped around. And so this order does matter. So since all of these come second now, the f is second, that means f, oops, I'm missing a parenthesis. That f is the input value now. Okay? So the base function is g. We're going to insert f into g. And essentially what your homework is going to be today is to do this for, you're going to be given two functions. You're going to find f of g of x, see what you get. You're going to find g of f of x, see what you get. Then you're going to find the domain and range. Now there's some problems in your homework where I threw the range out, but you're still going to find the domain. It's not really the point of what we're trying to do here, but it still ties back to some things that we've done in the past, which makes it relevant. Okay? Questions so far? Here's what your problem looks like. This will be a problem. Okay? It's going to say find f of g of x and g of f of x. And I'm not particular about the notation. You just have to choose one that you like the best. So this one means f of g of x. And this one also means g of f of x. And I'll go back, it's the one furthest on the inside. So therefore, that's the input value. All right, we'll talk more about that. State the domain and range for each. I will warn you of one thing. If you choose to use this notation, be very careful, to not make this little open circle look like the letter O. I get it. We look at this, and you can look at I've got memes on the wall that kids have made me over the years. I know this looks like fog. This looks like golf, and some kids made some memes and put those up there. So, but when you draw that, if you choose to do that, make the circle small, so you're not literally writing the word fog. Okay, so. Like I said, most of the time I think you're probably going to go with one of these. All right. Anyway, so let's go through the first one. F of g of x. Again, the order matters. That means the input is g. And here it is written out for you. Okay. Just in terms of what it means. G is the input value. So we're going to insert g into x. Because when we put a value in to evaluate, we replace the x's in that problem with that number. In these cases, instead of inserting a number, we are going to insert another function. Okay? So since g is the input value, I'm going to take g, which is x minus 6, and I'm going to insert it everywhere there's an x in f. Now, in this case, there's only one x, right? X squared. If this had an x on it too and was 2x, then I'd have to insert it there as well. Okay? Think about what we did when this would have been a number. Anywhere there was an x, we put that number in. Okay? It's a very similar idea, except instead of it being a number, it's going to be an entire function. Okay? So here's what that will look like. So first off, of course, I'm just putting g of x everywhere there's an x. And in this case, there's only one place there's an x. And that g of x is x minus 6. Now, I want you to be very careful with this because we have many people that continue to mess this up. This is the Batman meme. This does not equal x squared minus 36 or x squared plus 36. And some of you just insist on doing that over and over again, and you get it wrong. We talked about binomial squares, and there's that middle term, right? So if you don't remember what the shortcut is, I would recommend that you write out. So go ahead and finish that, simplifying that, and let's make sure we're all on the same page here. When you multiply this out, hopefully you got x squared minus 12x plus 36. Then I have a couple like terms. So f of g of x is x squared minus 12x plus 38. Raise your hand if that's what you got. Okay, are there any questions about what we did there? All right, now we're not done because it says state the domain and range for each function if they for each function. Okay, now let's start with the domain. Okay, we're talking about x values. Is there any x value that I cannot plug into this function that won't work? So, what value for x can't I ever plug in? Is there one? Okay, real numbers. Any real numbers that I can't plug into this? Okay, what kind of graph is this going to produce? Let's think about what it's going to look like. It's a quadratic, so what is that? What is the graph for a quadratic? Yeah. It's a parabola. Is it going to open up or down, and how do we know? How do you know?
X squared is positive.
X squared is positive, right? So I know that I'm going to have some kind of graph that looks something like that, right? And if you think back at our work that we did with quadratics, was there ever a situation where the domain wasn't all real numbers? Where we could, you can pick any value for x, no matter how far out I go, either way, it's going to hit the graph somewhere. Okay, so my domain is all real numbers. Now, since we know that the parabola is going to look like this, that's going to help us with our range. Right? Is this range going to have a floor or a ceiling? A floor. Now, how do I know what that floor is? Don't tell me what it is for this problem, but how do I know where the floor is? Like, generally speaking, where the floor is for a parabola.
On the x-axis.
Not necessarily.
Vertex.
Where on the vertex is the floor? the minimum, which is what? What is the minimum value for this floor? Nope. What is the vertex for this problem? Let's talk about the specifics now. Do you know what the vertex is?
24.
Nope. What'd you say?
12.
No.
24.
Nope.
Is it like the A, B's?
Nah, you don't have to do that. Look up higher in the problem.
6, 2.
6-2. How'd you get that, Julia?
3 is negative 6, you flip it.
Yeah, we have vertex form right here. 6-2 is the vertex, which means the floor is, we're talking about the range, so we're talking about y, 2. This is the floor. We did this before. Okay. Now, so there's not a y in this problem, but there's an f of g of x. So what we're going to say, range, f of g of x is greater than or equal to 2. Because 2 is the floor. We're talking about y's. Okay. Now, in some of your problems for homework, it's not going to be a parabola. Sometimes it's just going to be a linear equation, right? So it could be a straight line. It could be something different than that. So some of the problems when you go to find the domain and or the range, you're just going to have to look at it and try to think about it a little bit, right? See what you get. There's not always a hard, fast way to find the domain or range. All right. That is half of the problem. We have to find g of f of x now. Are there any questions before we do that? All right. Please try that one yourself. Again, just to be clear, in case you're struggling a little bit, f is the input now. Okay? So now f gets put into g. We're just going to reverse the order of which we insert. Okay, so what our deal is now we're going to take f and it goes into x in g. Okay? And again, if there was more than one x over here, I'd put it into other x's. All the x's. Okay? So here's where I'm at. Do I need the parentheses? Is it being multiplied by anything? No. So I can just drop them. All right, and then that's what you should have gotten. G of f of x equals x squared minus 4. Raise your hand if you got that. Okay. Now we got to go with domain and range. Any restrictions on the domain? Is there anything that x can't be? No. So remember, domain is all real numbers.
What is the situation where there's domain?
It's very rare. Very rare. It's very rare, and I can't think of one off the top of my head. It would have to be an x in a denominator somewhere, where it would make the denominator equal 0, or it would make underneath a radical negative, something like that.
Will you give us one like that?
Like, are you asking for one, or
No.
will I do that to you?
Yeah.
I'm not going to be that concerned about domain and range in this lesson. It's part of what we're doing, but it's secondary to what we're actually trying to do. Okay. All right. In the range here, what kind of shape do I have? Parabola, up or down? Okay, so I have a floor. What is the floor? -4, bless you. Okay, so this is actually the vertex form. Okay, remember, in order for this line to be the vertex form, the squared would have to be out here, not inside. So what is the actual vertex? 0, -4, okay? The other way you can think about this is a transformation. You take the parent function y equals x squared and move it down 4. Okay, that's another way to think about this. So my floor is -4. Another way to think about it, what is the smallest possible value for x squared? 0. Okay, the smallest possible value for x squared is 0. I can't ever be smaller than 0 if we're only using real numbers, right? Because anytime you square a number, it's positive. So if 0 is the smallest number I could possibly have, -4 is the smallest number I can possibly have for g of f of x. So that, again, just reinforces the idea that the floor is -4. Okay, so g of f of x for my range is greater than or equal to -4. Okay. Again, the main purpose of this lesson is not for you to work on domain and range. Don't get hung up about that. Do the best you can with it. But the main purpose of this lesson is to make sure you can do g of f of x and f of g of x. Okay? Don't spend a lot of stress on this. Okay?